This animated diagram shows a split-screen comparison of two identical flowing systems. On top, traffic moves smoothly at 70% capacity. On the bottom, the system is jammed completely at 100% capacity. We often assume that a team working at maximum capacity is operating at maximum efficiency, but physical systems tell a different story. Kingman's law explains exactly why this happens. It's a mathematical principle demonstrating that as a system approaches maximum utilization, even microscopic delays cause exponential spikes in wait times. A single disruption in a packed system creates a massive traffic jam. This exact physics principle applies to human teams. Scheduling every single hour of a worker's day leaves zero room to absorb unexpected tasks. When an urgent request inevitably arrives, the worker has to stop their current task, breaking their concentration and completely halting the project's momentum. Pushing a team to their absolute limit does not maximize their output. It mathematically engineers a traffic jam, ensuring nothing is delivered on time. When work sits waiting in these systemic traffic jams, it suffers from backlog rot. Backlog rot is the process where delayed tasks naturally lose their relevance and value over time. This timeline tracks a single piece of unreleased code, showing its measurable market value decaying toward zero the longer it sits in a queue. Customer needs shift, technology inevitably updates, and initial ideas grow stale, while the code waits to be finished. Unreleased work acts as hidden inventory that physically loses value every day it remains incomplete. Many organizations try to fix this decay by engaging in Agile Theater. Agile Theater is the practice of adopting productivity buzzwords and holding specific meetings without actually changing how the work flows. Measuring visible activities like meeting attendance or report generation gives leadership a false sense of security. It makes the team look busy and productive, while entirely hiding the underlying workflow rot. Adopting new vocabulary without restructuring the actual physics of a team's workflow leads to a predictable outcome. You guarantee the delivery of irrelevant products long after the customer actually needed them. This animated decision tree illustrates that fixing a broken system requires diagnosing your primary constraint, splitting into two distinct branches: steady work piling up or uncertain customer needs. You have to decide if your main problem is volume or direction. If your problem is a steady stream of work piling up, you use Kanban. Kanban is a workflow method built to handle steady bottlenecks by using strict work in progress, or WIP, limits. WIP limits are rules that intentionally restrict the total number of active tasks, acting like physical valves snapping shut to force the completion of old tasks before new ones enter the pipeline. If your problem is directional uncertainty, you use Scrum. Scrum is a framework designed to help teams adapt when they are unsure what to build or how customer needs might evolve. It acts as an insurance policy against wasting effort on the wrong product. By organizing work into short, structured check-ins, the team creates mandatory course correction mechanisms. They present what they have built so far, gather feedback, and ensure their output remains aligned with rapidly shifting customer demands. Selecting a framework is a purely structural decision. You are simply choosing the specific mechanical tool required to either clear a traffic jam or survive unpredictable market terrain. Some complex environments require a hybrid approach, known as Scrumban. Scrumban is a method that combines the continuous internal momentum of Kanban with the regular external alignment meetings of Scrum. The primary threat to any of these systems is a sudden, urgent executive interruption. Forcing a team to drop their planned work and switch context destroys their focus and stalls all active projects. This probability distribution bell curve plots expected delivery dates, contrasting a low probability early date of 50% against a safer high probability later date of 85%. To defend your workflow, you have to replace the illusion of fixed guessed deadlines with forecasts built on historical performance data. Presenting timelines as probability ranges changes the conversation. It forces leadership to confront the mathematical risk of injecting an urgent, unplanned task into an already optimized workflow. Defending a system requires stripping away the false comfort of absolute certainty. You force all stakeholders to make decisions based on statistical reality rather than wishful thinking. A modern business operates under one ultimate survival rule. A team must be able to deliver new ideas faster than the surrounding environment can change. Achieving this speed requires a counterintuitive sacrifice. You have to actively reduce the total amount of work your team attempts to do at any given moment. Drop the internal framework jargon entirely. Measure your system's success exclusively by its impact on real-world business realities, like increasing revenue and improving your ability to adapt. Perfectly executing a productivity framework is entirely irrelevant if the final product takes longer to build than the market is willing to wait. You must prioritize speed above all else.